Section 6.5 Conditions for Special Parallelograms. So, kind of looking at what we did in Section 3. What is the bare minimum amount to say that a quadrilateral is a parallelogram? In Section 5, what is the bare minimum amount to say a quadrilateral is a rectangle, or a rhombus, or a square? So we get to kind of have a flow to it. First, is it a parallelogram? Then, is it one of those special kinds of parallelograms? So first, conditions for rectangles. So if one angle of a parallelogram, so we're saying if it's a parallelogram. So you got to show it's a parallelogram first if you're not told that it is one. So you have to go to section 6.3 and do that process, then go to this process. So one angle of a parallelogram is right. Well, if it's a parallelogram, opposite angles are congruent, and the consecutive angles are supplementary. So supplementary to a right angle is another right angle. Same thing here, supplementary to a right is another right. So now we have a quadrilateral or a parallelogram with 4 right angles. So we have a rectangle. So all these conditions you want to put on the first page of your Chapter 6 notes. So the definitions, properties, and conditions for. Also, at a bare minimum, if the diagonals of a parallelogram are congruent, then you can say it's a rectangle. So kind of going step by step. First, is this quadrilateral a parallelogram? Then, if it's a parallelogram, is it one of these special types? And depending on what you want to show, you show this specific information. So then rhombuses also. First, you got to show the parallelogram, and then what's the bare minimum you need. So one pair of consecutive congruent sides. So one pair of sides that are next to each other and congruent. If it's a parallelogram, opposite sides are congruent. So EH congruent to FG, EF congruent to HG, and now we have all 4 sides congruent. So if it's the definition for a rhombus. So what's the bare minimum? If you have only one set of consecutive congruent sides. Also, another bare minimum threshold you could reach is if the diagonals are perpendicular. So diagonals of a parallelogram, so it's already a parallelogram, are those diagonals perpendicular? Or if only one diagonal bisects a pair of opposite angles. So you don't have to show both, you only have to show one. So line segment HF bisecting angle F and angle H. And that could be enough to show the rhombus. So you want to show the parallelogram first, then is it a rectangle or a rhombus? Now if you want to show the square, a square is a mashup or a composite of a rectangle and a rhombus. So to get a square, you got to go through a couple layers. Is it a parallelogram first? Then, is it a rectangle and a rhombus? If you can show both, then it's a square. So, given some of these problems, this quadrilateral EFGH may look like a parallelogram, a rectangle, or a rhombus, whatever, but go with your given information and use that to make a determination. So, want to look first? Is it a parallelogram? And then, if so, you can go to the conclusion. Is it a rhombus? So these are kind of like little puzzles. Given some information, can you apply that information and then make any conclusions? So for example, line segment EF and line segment FG are congruent. So mark that EF and FG. And e.g., that line segment is perpendicular to line segment FH. So the diagonals are perpendicular. Well, to be a rhombus, you want one pair of consecutive sides to be congruent. We have that. To be a rhombus, you want the diagonals to be perpendicular. We have that too. But to be a rhombus, you must first be a parallelogram. And unfortunately, we do not have enough information to say the parallelogram first. You want to show the parallelogram first, then show the rhombus. So we can't show this before this. So this conclusion is not valid. Remember, validity is different than truth. Could this be a rhombus? Sure, it could be. But based upon the information we were given, we cannot say the parallelogram first, so to conclude it's a rhombus is not valid. It could be, but we can't guarantee it. So we're not sure, it's not a valid conclusion. On the next page in your notes, there's a couple more examples. Take a look at those and then check your work with my completed notes online.